Hello friends, how are you? Hope you like my previous video. Today my topic is stress. What is stress? In general, the internal forces acting on area of cut may be varying magnitude and direction. So these internal forces are vertical in nature and maintain in equilibrium the externally applied forces. In mechanics of material, it is particularly significant to determine the intensity of these forces on the various proportions of the cut, as resistance to deformation and the capacity of the material to resist forces depend on the intensities. In general, these intensities of force acting on infinitesimal area of the cut vary from point to point, and in general they are inclined with respect to the plane of the cut. In engineering practices, it is customary to resolve the intensity of the force perpendicular and parallel to the section investigation. Such resolution of the intensity of the force of an internal area, the intensity of the force perpendicular or normal to the section is called normal stress at a point. It will be designed by the Greek letter as a particular stress generally hold true only at a point. It is defined as sigma is equal to limit delta F over delta A, where F is the force acting normal to the cut, where A is the corresponding area. It is customary to refer to the normal stress that cause traction or tension on the surface of the cut as tensile stress. On the other hand, those that are pushing against the cut are compressive stress. The other component of the intensity of force act parallel to the plane of elementary area. This component of the intensity of force is called shearing stress. It will be designed by Greek letter tau. Mathematically, it is written as tau is equal to limit delta A approaches to 0 and delta V over delta A, where A area and V is the component of the force parallel to the cut. It should be noted that these definitions of stress at a point involve the concept of letting delta L approaches to 0 and may be questionable from a strict atomic view of matter. However, the homogeneous model implied by this equation has been a good approximation to inhomogeneous matter on the microscopic level. Therefore, this so-called phenomenological approach is used. The student should form a clear mental picture of the stress called normal and those called shearing. To repeat, normal stresses result from forces component perpendicular to the plane of the cut, while shearing stress resulting from component parallel to the plane of the cut. It is seen from the above definition of normal and shearing stress that since they repeat the intensity of the force of an area, stresses are measured in unit of force divided by area. Since a force is a vector and an area is a scalar, their ratio, which represent the component of stress in a given direction in a vertical quantity. It should be noted that stress multiplied by the respective area on which they act give forces, and it is the sum of these forces at an imaginary cut that keep a body in equilibrium. In the English system, the usual units for stress are pound per square inch, and in this text as PSI. In many cases, it will be found convenient to use as a unit of force. The coined word KIP, KIP, meaning kilo pound or 10,000 elves. Thank you for watching.